Okay, so hopefully you've done your collaborate part 2 and you're looking at everyone else's and, just noting if any of the population means fall outside of the confidence interval. So keep taking a look at that until everyone has theirs entered to just kind of note what you see there. Okay, we've so far only talked about 95% confidence levels. What if we want one of those other two that are common, 90 or 99%? So look back in your notes or recall what piece of the confidence interval, the calculation of the upper bound and lower bound, relied on the confidence level. All right, think back. What value did we plug in to that formula that came from the fact that it was a 95% confidence interval? So hopefully you've looked through your notes, you're thinking about that, and you realize it's that Z value. It was that Z value of 1.96. And we have a special way to name that. It's a Z score. And in particular, it's a Z score that has area of 0.025 in the tail to the right of it. So that is how we identify particular Z-scores. If we want to talk about Z-scores in general that go with confidence levels other than 95%, we identify the confidence level as 100 times 1 minus alpha percent. That sounds way more complicated than it is. If we use our 95% example, so 95% or 0.95, if that's equal to 1 minus alpha, well, that means that alpha is 0.05. And if we go a step further, alpha over 2 is the area in just one of the tails. So that's 0.025. So, and we said that 1.96 was equal to Z sub 0.025, or in general, alpha over 2, if alpha is 0.05 and our confidence level is 95%. Okay, so in general, let's say we want a 100 times 1 minus alpha percent confidence interval. So that means that we're going to want to find the Z values that have area to the left and the right of those values of alpha over 2 is that area, alpha over 2 is that area. All right, so the Z values are Z sub alpha over 2 and negative Z sub alpha over 2, right? Which really the only one that we actually put into the confidence interval formula is this one. Okay, so we are interested in two others, 90 and 99%. So we're going to look at those specifically. But first, let's write down a general formula for confidence interval given any confidence level. The generic formula for a confidence interval for any confidence level is given to us by, we take x bar, the sample mean, and we're going to add and subtract to that to get the upper and lower bounds. So and now instead of putting in that 1.96 that goes with the 95% confidence level, we put in the appropriate Z value, which is the Z value that has area of alpha over 2 to the right. And then that's still multiplied by sigma over the square root n. There's 3 typical confidence levels, so we're going to identify what those Z values are, and then we don't have to look it up every time. 95%, we've already figured that one out. alpha is 1 minus 0.95. So alpha is 0.05. So that means alpha over 2 is 0.025. And we found that the z-value is 1.96. Let's look at the 90% confidence level. So 90% confidence level. So we want area of 0.9 in between those two z-values. And because that's 0.9, that means that alpha is 1 minus 0.9, so it's 0.1. Alpha over 2, divide that by 2, we get 0.05. So we have area of 0.05 in either tail. So the z-value we want is the z-value with 0.05 to the right. All right, so if you look that up, use your online normal tool. If you use the option for area just to the right, you're going to plug in 0.05. If you use the option for area in both tails, you're going to use the 0.1. All right, either way, you find a z-value of 1.645. Usually we round to 2 decimal places for z-scores. For various reasons, for 90% confidence level, the z-value we want to use is 1.645. Let's look at 99% confidence level. So the alpha is 1 minus 0.99, which is 0.01. So alpha over 2 is 0.005. All right, in between those z-scores, we have area of 0.99. So on either side, we have area of 0.005. So we want to look at that z-value, 0.005, from the online tool, and you will find that value is 2.575. Another one that we're going to go out 3 decimal places. Okay, so let's find confidence intervals for the true mean state by state tuition using these different confidence levels. So first we want to find a 90% confidence interval, and then we want to think about what's going to happen to the margin of error compared to the 95% and also to the width. So writing down what this confidence interval is going to look like. We've got 90% now, so we're going to have x bar plus or minus. Now we're going to use 1.645 instead of that 1.96 times sigma over square root n. Okay, we could probably already guess what happens to the margin of error and the width because we're using this value instead of 1.96. Let's go ahead and plug values in. 21,994 goes in there for x bar, and then plus or minus 1.645 times same standard deviation, same sample size. The only thing that changes is that 1.645. So evaluating, we end up with confidence interval going from the 17,977 for the lower bound to upper bound of 26,011. Okay, so remember we're wanting to compare the margin of error and the width to the 95% confidence interval. And for this one, we have margin of error. If we look at just this piece right here, that's the margin of error. We get 4,017, and then the width, which is twice that, we get 8,033. Okay, now we want to compare those to the 95% confidence interval. The margin of error is less, so we're adding and subtracting less, so that means that the width is narrower or smaller. Okay, so we can see that as we are less confident, we're only 90% confident, what we gain is a narrower interval, okay? It's slightly more precise. All right, let's look at 99% confidence interval. Okay, so we're going to take that same mean X bar value, 21,994, add and subtract. The only thing that's different is we're going to plug in this 2.575. Okay, that was that Z value that we found that has area of 0.005 to the right. And then multiply that by 5460 over the square root of 5. Okay, that's going to give us a lower bound of 15,706 and an upper bound of 28,282. All right, you can probably guess what's going to happen to what the margin of error here is. All right. For the 90% confidence interval, the 99% confidence interval, the margin of error is 6288. Okay, larger than it was for the 95 and larger than it was for the 90. And that gives us a width of 12,575. So again, the width is larger than for the 90 or 95. So we increased our confidence to 99%, but what we gave up was precision. We have wider interval, right? A larger range of values to capture that true mean. Okay, so we can summarize that by saying when the confidence level decreases, okay, so like going from 95 to 90, the more precise the confidence interval is. That is, the narrower the confidence interval is. If we go the other way, when the confidence level increases, all right, we have higher confidence, a larger probability. The less precise the confidence interval is, that is, the wider the confidence interval is. Okay, we have a couple more examples to do, but a few more observations to make about a confidence interval. We want to think about what else besides the z-score that we get from the confidence level impacts the width and the margin of error of the confidence interval. Okay, so that's besides the confidence level. I'm going to abbreviate that, confidence level. Okay, well, the other things that are in it is that population standard deviation sigma. Now, we're assuming that we know that value, and it's fixed, all right? That's not anything we can change, all right? The population standard deviation is what it is. All right, what is the other thing that makes up the margin of error? Well, it's sample size, it's n. And how does that impact the width and margin of error? Well, if n increases, all right, that's going to make that standard error of the mean, all right, taking sigma dividing by the square root of n, we're going to divide by something larger, so it's going to make it smaller. So that's going to decrease the width of the confidence interval. So increasing n will decrease the width of the confidence interval. And it is more precise. Let's look at this example. I'm going to have you go ahead and just read through that and then pause while you're reading and then pick back up. Okay, one way we can help ourselves when we are looking at a problem with a lot of words is identify the key pieces that we know. So we know that we are going to want to find 95% confidence interval for the mean, mu. Okay, that means we are going to calculate this. X bar plus or minus, all right, some z value times sigma over the square root of n. So we need to identify X bar, we need to identify sigma, we need to identify n. We need to pick those values out from all of those words. All right, so X bar, if we go through, we come across that they took samples from 20 newborn infants of cord blood. And at the end here, it says the mean number of targeted chemicals that they found in that blood for the 20 is 127.5. Okay, that is what we're wanting to estimate is the mean number of targeted chemicals. So our X bar is that 127.5. Okay, so now that's from the sample of 20. We're wanting to estimate for the whole population of newborns. Okay, now sigma, it is telling us that it is known that the population standard deviation sigma is 26. And our sample size, well, they sampled 20. Okay, the other piece we need is the z-score. Well, we have a 95% confidence interval, so that's always going to be that 1.96. So if we plug in the things that we know here, we're going to have 127.5 plus or minus 1.96 times 26 divided by the square root of 20. That will give us the interval with lower bound of 116.11 and upper bound of 138.90. Okay, and those are in chemicals. Now, just a note about rounding. On the previous example, I didn't round. The original data was given to us in whole dollars. And so if I had followed the rule, I would have rounded the confidence intervals to 1 decimal place. Well, because it's dollars, for me, it doesn't make sense to round to 1 decimal place. You either got to do no decimal places or you got to do 2 decimal places. So I just kind of skipped the rounding. Okay, but here, the mean is given to us, and actually the standard deviation is given to us to 1 decimal place. So we want to go 1 more decimal place. So that's why I went out to 2 decimal places for the upper and lower bound here. Okay, the other piece that we want is the margin of error. So the margin of error, right, remember that is just this right here. And if we calculate that, we get 11.40. Okay, so that's that margin that we're giving ourselves on either side of the mean to account for the error that is just naturally included in the sampling process. Now, that is calculating the confidence interval. Hopefully that's starting to seem, pretty simple, pretty kind of rote. You plug the numbers in, but we want to make sure we know how to interpret the confidence interval. Okay, what does it mean? Now you can go back to how the template of the wording that I gave you, but here's one way that we can interpret what this means. We could say we are 95% confident, there's our measure of reliability, that the interval from 116.11 chemicals, and I'm going to abbreviate to 138.90 chemicals, includes the true population mean number of chemicals in newborn's blood. Okay, so that's our statement of our population estimate. Okay, we are 95% confident that this interval that we have calculated from 116.11 to 138.9, that interval of values contains the true mean number of chemicals in all newborns' blood. Okay, one more question about this particular scenario. What's going to happen to that confidence interval if instead of just 20 infants, we test 50 infants? Okay, so when we ask about what's happening to the confidence interval, you want to think, well, is it going to get wider or is it going to get narrower? Okay, well, increasing n is always going to make the confidence interval more precise. Okay, so we will say the confidence interval is narrower, and it is because a larger n, a larger sample size, makes the margin of error smaller. Okay, we get less error due to sampling when our sample size is smaller. All right, that's probably another point to make. Less error in sampling. With a larger sample size, a larger n. Okay, let's look at this next example. Go ahead and pause and read that, and then we'll look at it together. Okay, again, we want to identify what's being asked of us and then go back and figure out, well, what are the pieces that we need to know. So we're going to want to find a 95% confidence interval for mu. So we just kind of write down, remind ourselves, this is what we're looking for. This is what we need to be able to fill in. Okay, so we want to identify X bar. Well, we can look at what's given. And from the sample of 50 footballs, we have a mean weight of 13.4, and it also gives us a standard deviation of 0.1. So we plug all those things in. We get 13.4 plus or minus. It's a 95% confidence interval, so we're going to use 1.96. We don't have to look that up. All right, and just refer back to the previous notes, or just remember. And then that's times the standard deviation of 0.1 divided by the square root of 50. Okay, calculating the lower and upper bounds. Okay, we're going to get lower bound of 13.37 and an upper bound of 13.43. And then calculating the margin of error, that's just this piece. Margin of error is 0.0277. Okay, so we got our margin of error, we got our confidence interval. Now let's look at this next question. It says, is the calibrated weight in the confidence interval? What does this imply about the machine? Okay, it says when the machine is properly calibrated, the mean inflation pressure is 13.5 pounds. Okay, so in other words, that's the target pressure is 13.5. All right, but 13.5 does not fall in the confidence interval. So 13.5 is greater than the upper bound of 13.43. All right, so the answer to that question is no. And what would we say it implies about the machine? All right, well, it's going to need to be recalibrated. All right, there's something off such that the footballs are being inflated to a lesser amount than they should be. So we need to recalibrate the machine. Okay, one more question. If we sample 150 footballs instead of 50, what's going to happen? Well, hopefully we're getting the swing of this, and it is going to make the confidence interval narrower. And just like we said in the previous example, a larger N means or leads to a smaller margin of error. Okay. All right, one more part to the collaborative activity. So now you can go ahead and find the 90% and 99% confidence intervals based on your sample. There's tabs for each of those. Really the only thing that's going to be different is you're going to change that Z value that you plug in. So plug in those and lower and upper bounds for both of those tabs, both of those levels of confidence, and then they'll show up on the scatter chart, and just look and see what you notice about yours and the others and how they compare to the population mean.